Okay, so we have the boundary of this parallelogram. It's called C, and we want to find the line integral of this vector field around C. Okay, so notice a couple of things here. The first thing to notice is that we are going in the clockwise orientation, not the counterclockwise orientation. So there's two ways to do this problem. One way is just to do this from the definition of line integrals around vector fields. The other way is to use Green's theorem, and that's what we're going to use. We're going to use Green's theorem. Okay, so this is the P component. This is the Q component. And so what Green's theorem says is that the integral that we care about is going to be the area integral over the parallelogram, which I'm calling R, of Qx minus Py. So the derivative of Q with respect to x is 9. The derivative of P with respect to y is equal to 0. Okay, but notice Green's theorem, to do Green's theorem, the boundary has to have counterclockwise orientation. This has clockwise orientation, so that just means we need to multiply this integral by -1. Okay, really the way to think about this is we're multiplying, let me just say it this way. Really, what we want to find is this. Okay, this is equal to minus the line integral around C in the counterclockwise orientation. And by Green's theorem, this integral is equal to that integral. Okay, so think through that if you didn't follow it all the way, but remember, orientation is very important. Okay. Well, so now there's a couple of ways that we can do this problem. This is just equal to 9. This is just equal to 9 times the area of the parallelogram. Well, what is the area of a parallelogram? It's just equal to the base times the height. So the base is 2. The height is this distance right there, which is also 2 times 9. Put the minus sign. So this is equal to minus 36. Okay, let's do a slightly more difficult problem, though maybe not much more difficult. Instead of the Q component being 9x, let's say it's 9x squared. And so now we want to do the integral over the region R. The x derivative of Q is now going to be 18x dA. Okay, so we want to do this integral. Notice if we do the x integral, notice if we do the y integral on the inside, we're going to have to split it up into two pieces. We're going to have to, one, do this part, and then next do that part, okay? So we're going to have to split it up into two integrals, one where x goes from 0 to this boundary, and one where x goes from this boundary up to the top boundary. Okay, so it's better to do the x integral on the inside because it's always going to be from this boundary to that boundary. So we're going to do the x integral on the inside. So to do that, we need to get an equation for these lines. So this is y is equal to 2x, and the equation for this line is y is equal to 2x. Sorry, this is y is equal to x. And this is y is equal to x minus 2. Okay, so the x integral, x is going to go from y to y plus 2, and then y is going to go from 0 to 2, and we're integrating the function 18x dx dy, and now this is a problem that you can finish on your own.